Hi there, welcome to Mr. Morgan's Math Help for Algebra 1. We're in Unit 1 still, one variable statistics, and looking today at Lesson 14 about outliers. Learning goals. Let's investigate outliers and how to deal with them. And our targets is I can find values that are outliers, investigate their source, and figure out what to do with them. I can tell how an outlier will impact the mean, the median, the IQR, or standard deviation, because an outlier is going to have effect on all four of those numbers, and some of them more than others. Alrighty, here we go for today. It says the histogram and box plot show the average amount of money in thousands of dollars spent on each person in the country per capita spending for healthcare in 34 countries. So we're looking at money spent in 34 countries. All right. So, what do you notice about these charts here? What are the things you see when you first kind of take a look at them? A couple things you might notice is we have just most of them's right here. All right. And then we have this one value out there. And then when we look at it as a box plot, we can see that in terms of our interquartile range, we're here, right? Our box is here, with a little minimum value there, but then I have this other value way out there. So things are definitely what we would call skewed to the right, correct? And what's causing that? What's causing us to pull out there? Well, it says one value in the set is an outlier. Which one is it, and what's the approximate value? Well, based upon what we see, the outlier is going to be the one that's way out of bounds with the rest of the stuff. Everything is kind of grouped together, and this one's hanging out by itself. Approximate values, hard to say. We know in this graph that it's between 9 and 10 thousands. And over here, we can kind of draw a line because of the box plot and plot it down there at maybe 10,000, right? So it's hard to say exactly which one it is, but it's somewhere between 9 and 10,000 and probably closer to maybe about 10,000. All right. And that's in thousands of dollars. So by one rule for deciding a value is an outlier if it is 1.5 times the IQR greater than Q3. Show in the box plot whether or not your value meets this definition of outlier. Okay, so let's just see what that means. What this is saying is that if I find my IQR, which is Q3 minus Q1, right, that's my IQR value. When I find out what that value is going to be, we'll call that number n, okay? And then I take that number n and I multiply it by 1.5, okay? That's going to give me a new number. That number, we'll call it, let's call it y, okay? Just making up letters here. That number, if I add it to y, okay, whatever that number is going to be, anything greater than that is going to be an outlier. In the same way, sometimes anything, if I subtract y from Q1 and it's less than that, that would be an outlier. So we can have an outlier over here as well. We can have it in the small side. In this case, we don't. So that's one rule of figuring out if it's going to be an outlier. You take the Q3 minus Q1, and then whatever that value is, multiply it by 1.5, and then we add that value to Q3 to see. So in this case here, let's take a look. Q3 is here at 5. Q1 is at 2. So I would do 5 minus 2 equals 3. Okay. Now I'm going to take that value and multiply it by 1.5. Well, 3 times 1.5, 15 is 4.5. It's 4.5. So that's my y value. So now I'm going to take the 4.5 and add it back to my Q3 value, which was 5. So that equals 9.5. Okay. So if I'm saying that my outlier is 10,000, well, 10,000 is definitely greater than 9.5. So that means that that value would indeed be an outlier. Okay. Now, if I thought it was only 9,000, for example, it's not necessarily an outlier. It's close. So this is the rule or the way of figuring out if something's an outlier numerically. but you still have to decide what to do with that value and what does it mean, because it's here for a reason. Someone collected information about the amount of money spent on people. So why is that there? Is that a mistake? Is that accurate? Those are the statistical questions that we have to answer and when we find things like this in our math work. Okay? So that's what we're looking at today. Investigating outliers. So here's a data set used to create the histogram and box plot from the warm-up. So this is the data that made these charts right here. Use technology to find the mean, standard deviation, and the 5-number summary. Okay, so I'm not going to use my Excel spreadsheet real quick, but let's just write these down. Okay, so you can definitely plug them in and figure them out. So we have our mean, which is our average. We have our standard deviation and our 5-number summary. Okay, so our mean for this one, mean is going to be when you add them up and then we divide by the number. I have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. 8 times 4 is 32, 33, 34. So I have 34 values here. All right. So when I add those up and divide by 34, my mean is going to be 3.7259. Okay, so that's my mean. That's my average of all those values there, 32.759. So really, if I think about it, it's happening somewhere about, these are in order, somewhere about here. Oops, change my eraser again. So this is about where my mean's going to be. If you were to line these up, it happens there. The standard deviation is going to be how far each value is away from the mean, essentially. Basically, you take the mean of the mean and find the difference. And so that was a calculation on our Excel spreadsheet. The standard deviation in this case is 1.827. So most values are within 1.8 of the 3.7 value. So 3.7, I think about this, 3.7 minus 1.8, we have here 1.9, 3.7 plus 1.8, I'm at 5.5. So I can see here that that includes that value all the way up to 5.5, which is going to be here. So indeed, most of the values are in that range right there from the first one to there, and there's my mean based upon our standard deviation. For our 5-number summary, we would then take a look at if there's 34 numbers, we're going to split it at 17. We know this is 16, this is number 17 right here. So 17 is my splitting point there. Okay, so I'm going to split there. I have my minimum value, I have my maximum value. So my minimum, my maximum, I have my median number, which is going to be right there between 3.3 and 3.5, right? So we're going to say our minimum is 1.08. We're going to say our median, I'm just going to estimate it for now, is about 3.4. It's between those two there. Our maximum is up here at 9.8. And to find the interquartile range, we find the middle of each of those. And so the middle of each of these values here is going to be, this one is Q1. And then over here, this value right here is Q3. So 2.1 and 4.8. And I'm just making my numbers a little smaller just so I can work with them. Okay, so now we have our 5-number summary, good to go. The maximum value in this data set represents the spending for the United States. Should the per capita health spending for the United States be considered an outlier? And that really is the question of the day. You have all these numbers here, and then you have this 9.89, and that it's a far out number from the rest of them, right? And should it be considered an outlier? Okay. Well, when we think about a number like this, we know that it's doing something to our overall values, right? It's changing things. So the way you'd figure out if it's an outlier or not, again, if we do mathematically, we're going to take our Q3 minus our Q1, and whatever that value is going to be, I'm going to multiply it by 1.5, and that's going to give me a value of n. Then I'm going to take the n value and add it to Q3, And that's the number I'm going to use to see if this 9.8 is larger or smaller. So in this case, when I do this, Q3 minus Q1, okay, Q3 is about 4.8, Q1 is about 2.1, so we're about 2.7 for our n value. I multiply that by 1.5, and again, I'm rounding my numbers quite a bit, or truncating and chopping them off. So we have 13 there, we have 7 and 2, so we're going to have 5, 10, carry the 1, 4.05 or so, about 4.05, something like that. So I'm going to add that value to, so 4.05 to my Q3, which was 4.8. So I end up with 8.85. Okay, so anything greater than 8.85, according to my kind of formula to find if something's outlier, is going to be considered an outlier. So we would say that yes, based upon this, yes, it's an outlier. But the question is, should we consider it an outlier? Yeah, we should, but then it's a question of what do you do with it? Do you keep it or do you not? That's the question, okay? So in this case here, we could write down that we know that 9.89 is greater than what's an acceptable number to be considered an outlier, all right? So questions, do you keep it? Well, it does exist. You can't just ignore that that amount is an actual amount. So that's what a statistician does. You're going to take a look. A statistician does. You look at these numbers and decide, do I want to include that or not? Obviously, there's a big difference between that value and the minimum value. So whatever country this is, they don't spend a lot of money on healthcare, and this one, obviously, we spend a ton. Keep going with the same numbers. Although outliers, number 3, should not be removed without considering their cause, it's important to see how influential outliers can be for various statistics. Remove the value of the United States and then see what happens. So we're going to take this value out and see what happens to the data. Now, just to do this real quick, before we had our mean, our standard deviation, and then we had our 5-number summary. Okay, I'm going to write them down in orange real quick. I'm just going to make them a little smaller. We had 3.7 about. We had our standard deviation of 1.8. And our numbers over here for our 5-number summary, we were looking at 1.08. I think I'm going to run out of room here. 1.08. I keep turning the page, not going. 2.1. 3.4. 4.8. And 9.8. So let's change colors real quick and figure out the new mean and standard deviation and 5-number if we don't include the United States. So first off, with our 5-number summary, the minimum stays the same. Our maximum definitely changes because now we have 6.6 as our maximum value there, okay? And so then what's going to change is things like now my median. So there's my minimum, my maximum. My median before was right here. We're going to slide it back probably 1 number, right? So my median is going to be over there at 3.39. And now my Q1 was here. So now I'm going to go between there and there. So I can still say, I'm just going to write down 2.1, not too much of a change here. My last median value was over here. My Q3 was there. So now it's going to be between those two. So we could say about 4.7. It's not going to be too far off there for Q3. So 4.7. In terms of the mean for this value set here, the mean is going to be actually now 3.5. And then the standard deviation is 1.5. Okay, so by getting rid of that outlier, we can see that our mean value decreased, our standard deviation decreased, which means that the values are all closer to the mean now. When it comes to our 5-number data set, definitely the maximum changed. And we can also see the other big change happen to, and this was not a huge change, happened to our median number, a little bit of change there, and our quartile 3, we had a small changes there. Not a huge number change between the 5 numbers, all right? So we can see, in a sense, our IQR values have little change, right, when you move those outliers there. But these have a lot more change, and that's because the mean is greatly impacted by that outlier. And the standard deviation is, of course, connected to the value of the mean, so it's also impacted by it quite a bit. So when we look at these things here, the mean and standard deviation are the two values of center, or measure of center and variability, most impacted by an outlier. Whereas the median and interquartile range are less impacted, right? I mean, here's our median value there, and our interquartile range really isn't going to change too much. When I subtract that or subtract that, we're talking about a tenth of a difference. Very, very little change. But this is a significant change here, and so really it depends on what information we want to look at. If we're just trying to find the basic middle of something, then it's not a big deal. But if you're working with the mean, those outliers are going to have a huge impact on your values. All right. Okay, so just keep that in mind there. All right, activity 14.3. The number of property crimes, such as staff reports, is collected for 50 colleges in California. Here's some statistics. We have the 50 colleges there. We have the mean at 191. So as a point, we could just put a point here. Here's about where the mean's at, right there. An interquartile range, if you were to use these numbers here, we can see that the median is about 107. So that's going to be over here. So that's our median values there, or our mean values there. Very different, right? Spread apart quite a bit. 191 compared to 107. Are there any values that are outliers? And explain or show your reasoning. Well, to be an outlier again, we're going to take Q3 minus Q1. Then we're going to multiply that by 1.5 to give us that value of an outlier. We will then take that value and add it to Q3 and see if a value is going to be greater than it or not. Okay, so for this we have 260 minus 15, which is going to get you 245. Okay, doing so okay so far. That's our Q3 minus our, I wrote the wrong number. I'm not doing okay so far. Gotta write the number. We got to do minus 52. 260 minus 52 is 202. Now I'll take that value and multiply it by 1.5. When I multiply by 1.5, I end up with 312. And then I'm going to add Q3 back to it, which is 260. So now I'm at 572. So anything greater than 572 is going to be considered an outlier. Okay, this is Q3 minus Q1 times 1.5 plus Q3. So what numbers are greater than 572? Well, we have 593, 699, and 768. So we do indeed have 3 schools that are greater than the acceptable number for an outlier. So there are 3. If there are outliers, why do you think they might exist? Well, why might you have a lot more crime or theft in some colleges than others? Probably depends on the school size you go to. For example, my son goes to a school called Westmont in Santa Barbara, or Montecito, which is about, 20 minutes, 50 minutes away from UC Santa Barbara. Okay? His school has a number of students. I want to say maybe 1,800 students are at that school. Whereas UC Santa Barbara, I don't know what it is exactly, but it's probably more like 25,000 students. So in terms of crime happening, there are fewer students here than here, so I would expect a smaller number at this school and a greater number at this school. Not because one's better or worse, just because there are more people, so more things are likely to go wrong, potentially, is what we would say there. All right, so let's look at another situation. These situations described here have an outlier for each situation. How would you determine if it's appropriate to keep or remove the outlier when analyzing data? Okay, so how would you decide? Well, let's see. A number cube, it has size labeled 1 to 6. After rolling it 15 times, here's the data. 1, 1, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 5, 6, and 20. Well, that 20 is definitely way outside the range. Should we keep it and use it as part of our data or not? Well, knowing that we're rolling a dice that has numbers 1 to 6, the question would be, how did you roll a 20? It's not even possible, right? And since it's not possible to roll a 20, we're going to want to get rid of that value because it doesn't make any sense. That's just a mistake made in the calculations. How about B? The dot plot represents the distribution of the number of siblings reported by a group of 20 people. Some people have no siblings, 1 sibling, 2 siblings, 3, 4, 5, and someone over here has 12 siblings. Okay, now we have to decide, do we keep that or do we not? If I want to do the mathematically and figure out interquartile range in Q3, minus Q1 and all that stuff, maybe I could do that and say, well, that's going to be something like 3 minus 1 is 2. I add 2 to there, so anything bigger than here is going to be an outlier. Mathematically speaking, we could say, yes, it's an outlier. The question for us is, do we keep or remove the outlier? That's what we want to decide. In this case here, it's really a question of, well, was that accurate? Let's go back and ask the people and say, did we write down your result correctly? Did you say 12? Did you mean to say 12? Did I make a mistake? Maybe someone has 12 siblings. That is possible. So we just don't know. We'd have to ask a question to follow up and see if our results were accurate. Here's science class. It says in science class, 12 students are synthesizing biodiesel. At the end of the experiment, each group recorded the mass in grams of the biodiesel they synthesized. The masses are 0, 1.2, 1.2, 1.3, 1.3, 1.4, 1.4, 1.5. Okay, so everything is pretty much in the 1.2 to 1.5 range with the exception of the 0. So the question is, that's the one that doesn't belong. That's an outlier. Do you keep it or do you reject it? You have to decide what might that be. So probably since this is a group of students doing an experiment here, we'd have to decide, are their results accurate? And that's just the question you'd have to decide. You'd have to investigate a little bit further to see if the experiment was done correctly. Did they make a mistake? Did they make an error in their calculations? I mean, how many times watching my videos have you seen me make a mistake in my calculations? It happens all the time. So when you're looking at data like this, you know what? You might have to just go, maybe I did something wrong, and use the eraser and figure it out. So one that may or may not keep, I don't know. Probably it's a wrong number, and you probably want to get rid of it so that your data for your means and things like that aren't all off. All right, so here's your summary for this outlier information. The key thing here today is just knowing, one, how to figure out the outliers, that method there of the Q3 minus Q1 times 1.5, get you that value there, and then adding that to Q3 to then see if it is going to be greater than that value there. That's kind of your mathematical way of looking at it. You can tell on the different charts and graphs if something is an outlier, but then the big thing is, what do you do with it? Do you want to keep it or toss it? And that's where you have to use some math and some thinking to decide what's going to be the best thing to do with that information. So this is your summary statement here. You can read through those there, and that's really what it is. The only final thing we'll say here is remember that the mean and standard deviation are affected the most by an outlier, whereas the median and the IQR are minimally affected. Not a big deal. So it depends on what you want to look for. If you're just looking for the middle of something or the kind of normal range, then the outlier is not a big deal. But if you want to start working with the mean, you need to probably figure out, does that outlier belong or do I get rid of it? All right, here's your cool down for the day. And we'll move on over to your homework. And here we go for some homework review. The number of letters received in the mail the past week is recorded. 2, 3, 5, 5, 5, 15. Which one appears to be an outlier? Well, which one doesn't quite fit? Let's go with the one that's way out here. 15 makes the most sense. Elena collects 112 specimens of beetle and records their links for an ecology research project. When she returns to the laboratory, Elena finds that she incorrectly recorded one of the links of the beetles as 122 centimeters. Oh no, about 4 feet. That'd be a very large beetle. What should she do with the outlier 122 centimeters when she analyzes her data? Okay, Well, it's a pretty bad number, right? She could do a couple things. She could either get rid of it completely and just say it was wrong, okay? Or she could go back and she can do a whole recount or remeasure all the numbers to make sure she is accurate there. You know, as a scientist, you might want to be precise in what she's doing, so it might be good for her to go back and almost start over. Go back and remeasure all 112 to see where the error was made, just to make sure the data is accurate. Is it going to change a ton by redoing it all? Probably not much. She might be fine just getting rid of it and just keeping it like that and really making her specimen count 111 instead of 112. Depends on how much time she has and how much work she wants to do. May took a survey of students in her class to find out how many hours they spend reading each week. Here are some summary statistics. We have our mean at 8.5, standard deviation at 5.3, and here we have the information about median, Q1, and Q3. Okay, so a couple things we see here. Our median is definitely in a different spot than our mean, right? A little less there. So give an example of a number of hours larger than the median, which would be an outlier. Well, to be larger than the median, we have to find out what an outlier is going to be. So 11 minus 5 is 6. Multiplying that number by 1.5, we get 9. We add the 9 to our Q3 value, which was 11, so 20. Anything greater than 20 would be considered an outlier. So if we said that someone read 25 hours, that's going to definitely be an outlier. It's larger than the median, and it follows the rule there. So you do have to kind of remember how that works. Q3 minus Q1, multiply that by 1.5, gives you a number. Take that number, add it to Q3, and that's what you're going to see. Is it greater than that? Okay, if it's bigger than that, it's an outlier. Are there any outliers below the median? Well, let's look here. If the number I have to work with is 9, then I'm going to take that number, and remember with Q1, you can do Q1 minus that number. In this case, it's going to be 5 is Q1 minus 9 equals negative 4. Well, that is a number, right? But can you read negative 4 hours? No, you cannot read negative 4 hours. So it's not possible to have an outlier below the median there. Not possible. All right, number 4. The box plot shows the statistics for the weight in pounds of some dogs. Are there any outliers? Explain how you know. All right, so let's see. Q3 is here at 55. Q1 is here at 35. So 55 minus 35 is 20. We multiply that by 1.5. Okay, so 5 times 0 is 0. 5 times 2 is 10. And then we have 0 and 2. So 1 decimal, 30. We're going to add that to Q3, which is 55. So any number greater than 85 is going to be considered an outlier. So here's 85 right here. And we can see for sure there's a maximum value at about 95. So, are there outliers? Yes, there are outliers. How do we know? Well, we did the math to see what our number was going to be, and we looked and saw that maximum value, and we can certainly tell there is an outlier. Number 5. The mean exam score for the first group of 20 examinees applying for a security job is 35.3 with a standard deviation of 3.6. All right, so 35.3 with a deviation value of 3.6. For group 2, the mean score was 34.1, so a little lower. Standard deviation of 0.5, less variance. Okay, very symmetric, no outliers. Use the mean and standard deviation to compare the scores to group. Okay, so with group 1, we have a higher mean. Okay, group 2 has a lower mean. But that higher mean also comes with a greater variability based upon the standard deviation. This low mean has less variability, which means most of the values are right around that same spot. So most people in group 2 are around 34, whereas in group 1, you could have anywhere from 32 up to 38, okay, if you were to kind of make a plus or minus with 3.6. The minimum score required to get an in-person interview is 33, Which group do you think has more people get the in-person interview? Well, based upon the variability, I would probably go with group 2 because most people are going to be at 34, which is above the 33. Whereas group 1, while the average is at 35, that's great, there are going to be a number of people that are below that number. Okay, not a ton, but definitely group 2 is going to be a little more effective. And finally, our last section here. A group of pennies made in 2018 are weighed. The mean is approximately 2.5 grams with a standard deviation of 0.02. That is super small. Interpret the mean and deviation. Well, it means on average they all weigh 2.5 grams, and for the most part they might be a little bit bigger. 2.52 might be the heaviest one would be, so not much change there. That deviation is so small that they almost all weigh exactly the same. Can't be perfect, but it's pretty close. 7. These values represent the expected number of paintings a person will produce over the next 10 days. What are the mean and standard deviation of the data? All right, the mean and standard deviation of this data here. Well, the mean is we're going to add those numbers up. And when we add those numbers up, they're going to both be 1.5. Okay, so mean standard deviation 1.5. That's about where he does. So he does about 1.5 paintings a day, plus or minus 1.5, which means your high is about 3 and your low is about 0. That's kind of your spread there. The artist is not pleased with these statistics. If the 5 is increased to a larger value, how does it impact the median, mean, and standard deviation? Well, for the median, it's not going to change it too much, right? Adding that outlier is not going to change. So little change for that one there. But the mean, by adding an outlier of to like 20, it's going to go way up, and the standard deviation is also going to increase. So having an outlier is going to have a bigger effect on the mean and the standard deviation. Our last one, number 8, list the 4 dot plots in order of variability from least to greatest. So the least variability to the greatest. Well, our least variability is going to be here. That's our first one because everything is exactly the same. Okay. Now when I look at the other ones, this one is definitely the most spread out. So that's going to be number 4. And now I'm going to compare these two. Variability is kind of the spread of the data. Here the numbers are spread between 4 points. Here they're spread between 1, 2, 3, 4, 5, 6, 7 points. So least variable is the 1 pointer, the 4 points, the 7 points, and the 8 million points. And that's how I would do that there. Hope that helps you out. Hope you're getting the idea of outliers. And that's it for today. We see you next time for another lesson. Have a good day. Bye.